this video, we're going to focus on a review of the logarithm. You might remember learning logarithms for the first time in Algebra 2 or pre-calculus. We're going to just briefly review them so that we're ready to use them in our logistic regression model. First, let's refresh on what that logistic regression model looks like. Remember, we already know the right-hand side. It's the same as in a linear regression model, but we need to understand logarithms to better understand this new thing on the left-hand side. Remember that p over 1 minus p is the odds ratio. So take this opportunity to go back and review the odds ratio if you need it. Now we're going to look at the thing that's on the outside of the odds ratio here in the red circle, the logarithm. The log is a function that takes a number and returns a number. So you can take the log of 4, or the log of 200, or the log of 6 billion, and get a number back. So type into the calculator or to R log of 6 billion, you'll get a number back. You can't take the log of any number that's less than or equal to 0. But this is okay with us because we're taking the log of the odds ratio. And the odds ratio will never be negative because it's made up of probabilities. The probability of success is always going to be between 0 and 1, and the probability of failure is always going to be between 0 and 1. So a positive number divided by a positive number is always going to be a positive number. We'll never have a probability of success of 0 or a probability of failure of 0, because if we did, this wouldn't be an interesting problem. If the probability of something happening is 0, then we never have to worry about it. Our prediction will always be that it doesn't happen, and we won't have a model in the first place. So this will never happen. P will always be small or large, but some number that's not 0 and is not 1. So we don't really have to worry about taking the log of the odds ratio because it'll always be some non-zero positive number. So what happens when we apply this logarithm function? Let's start by looking at the natural log function. Look at that horizontal axis. It goes from 0 to 10 in this picture. We'll call it x, but we're going to think of it as the odds ratio. And the vertical axis is labeled log of x. So this would be the log of the odds ratio, or the left-hand side of our logistic regression model. The first thing I want you to notice is that all values of the function, or the black curved line, are to the right of x equals 0, but we know that we're never going to take the logarithm of something that is less than or equal to 0. So this is in line with our expectations. The second thing I want you to notice is that it crosses the horizontal axis at a value of x equals 1, at a value of the odds ratio equals 1. Well, when the odds ratio equals 1, as we talked about in the last video, it means that the probability of success is equal to the probability of failure, numerator equal to denominator. And if they're equal, it means they're both 0.5. So the probability of success is 0.5 and the probability of failure is 0.5. So I'm saying I have no information. I can only give you a coin flip about what's going to be the outcome in this situation. So when x equals 1, when the odds ratio is 1, the log of that value is 0. If the odds ratio is less than 1, the log odds ratio will be less than 0. And you can see that in the picture because the curved line, here, this area, okay, that's between 0 and 1. So x, the log odds ratio, is between 0 and 1, and we see that we have values between 0 and negative infinity when that's the case. It would mean that p, the probability of success, is less than the probability of failure because the odds ratio is less than 1. So if the probability of success is smaller than the probability of failure, then we'll have a log odds ratio that is negative. Similarly, if the odds ratio is greater than 1, the log odds ratio will be greater than 1. So we're talking about this area, okay? the x input is bigger than 1 and the output is bigger than 0. And in that situation, p is greater than 1 minus p. So we said the odds ratio was greater than 1, so the numerator has to be bigger than the denominator. P is greater than 1 minus p. So that's how the odds ratio and the output, the log odds ratio, are related. When we put one thing in, we get one thing out. Okay, so if the odds ratio is bigger than 1, we're going to have a positive log odds ratio. And if the odds ratio is less than 1, we're going to have a negative log odds ratio.